This video is intended to be a crash course on how to waterproof an ESC. I've learned the hard way that waterproofing an ESC is definitely trial and error, and mostly error for me. And this is the third one of these that I've had. Bought them from Leader Hobby for like $12. Yeah, $12 for a 60 amp water cooled Skywing ESC. And this, like I said, this is the third one I've had. As they've burned up, I've taken them apart and studied them to understand why they burned up until I got to the third one. And each one I made a few more improvements on. The very first one that burned up, the way these are put together is these water blocks sit on top of a silicone pad that sit on top of the MOSFETs like that, and that conducts the heat away, and that's how the heat's carried out through heat transfer to the water block from the MOSFETs. And all this structure, or this assembly, is inside this heat shrink right here. And I took liquid electrical tape and just poured it in the ends of the heat shrink tubing and let that set up, and I thought that'd be good. And the ESC failed within minutes. And when I cut it apart, water came out. And so I started wondering how could water get in there, and I soon realized that the water had actually leaked from these brass nipples where they thread into the aluminum. So all that water leaked out of that fitting right there and was trapped inside the two ends that were sealed, and that water was trapped inside, shorted itself out. Okay, so on the next revision of that same speed controller, I cut the heat shrink off and I did a very liberal coating of liquid electrical tape on the whole thing. And things were going good with it until I had a water cooling line come off my water inlet on the back of the boat. And so it was pumping water into the hull of the boat, but not to the ESC and the motor to cool it, and it was slowly flooding the boat on the inside. And I didn't realize it until it was too late. But what had happened is this ESC got so hot with no water going to it that the liquid electrical tape actually melted and exposed holes in the seal to the circuit board. And as the hole was filling with water and being flooded, and the liquid electrical tape got hot and allowed a leak, well, once again, water got to the MOSFETs and shorted them out and stopped working. So I've kept these parts from each one. I got 3 water blocks now, and this is the new ESC, which I've already cut open with an X-Acto knife just to get the heat shrink tubing off of it. And what I'm trying now is a product called 3M Scotch Weld Epoxy Potting Compound. You can get this in black or clear. I prefer the black, just so you can see how much coverage you're getting on individual components. This is a 2-part epoxy. You mix it up. I used little ketchup containers from Burger King and little mini popsicle sticks, and mix it up in there, and then just take your popsicle stick and just dip it on everything and just coat the whole damn board. And that's what I've done here. Did this about 14 hours ago. And this is a hard 2-part epoxy. And there's the heat sinks, or the MOSFETs right there that the heat sink goes onto. That's what generates the heat in an ESC. On this side of the board right here, this is where the MCU, which is the memory control unit that executes the software to run the program for the drivers to switch these MOSFETs at like 16,000 times per second to regulate the 3 phases of current going through to the motor. And then this other little circuit board here that's flipped up, all that is the BEC circuit. That's what takes your LiPo battery voltage and steps it down to 5 volts to come out your servo lead right here to power your RC system with. And so I coated everything with this epoxy stuff. Now, when these things are made, they don't do a very good job of getting these MOSFETs flat across the top. That's why they use this silicone pad on top of the fets and then put the heatsink on top of that, trying to make up for the inaccuracies and the non-flatness of these fets. So I'm going to let this epoxy dry a little longer, but when it's all said and done, I'm going to put this onto a sanding block with some high grit sandpaper. I'm going to sand the epoxy off the tops of the fets and actually sand into the fets a little bit and get a perfectly flat plane across the top of those fets. And I'm also going to do the same on the water block. And like I said, make sure you seal these brass nipples going into the aluminum. So once the top of the fets are sanded and the water block is sanded flat, we're gonna make them together, and we're gonna do it with this product here. We're going to do away with the aluminum or the silicone heat transfer pad that they originally used. We're going to do away with that. We're going to use Arctic Silver illumina thermal adhesive. It's basically a two-part epoxy ceramic. Now this is like heat sink compound that you'd use on a computer, except this is two-part epoxy and it's a permanent bond. It will never release, and they warn you of that too on the package. This is a permanent heat transfer paste adhesion. So yeah, once I get the fets sanded flat and the block is flat, we're going to permanently attach the heat sink to the top of the fets with the Arctic Silver. Now I'm hoping this will be the end-all, be-all waterproofing solution for an ESC. I hope. Got my fingers crossed. The coating looks really good. I'm really happy with it. So this is what we've done so far. I showed you the two products that we use to hopefully be the ultimate solution to waterproof your ESCs. So I'll be doing a follow-up video on this at some point, showing the finished product, and then showing a video of it in the boat running, and we'll also see how it holds up over a period of time out on the water. Thanks for watching.